one heard the question. You gonna need to memorize anything if you have all the formulas? No. Okay. So all we expect you to be able to do is to apply the formulas. Okay. The other thing, just like we did last semester, okay, so any test grade you have that's lower than the final exam, so say you had a 70, a 60, an 80, and a 90, and let's say you get an 85 on the final, okay, I'm going to wipe out these three and put an 85 in for those three, okay? So just like we did last semester, if you got a 95, I'll wipe them all out. Okay, and put in that test score. All right, so hopefully that motivates you to study. When are we taking the final? Monday and Tuesday of next week. We are going to do the final on the computers again, okay? But as we ran into some internet issues yesterday, you guys were the only ones that had the issues. So what things that we got to remember when we're doing this, because it is new, and the internet's only so reliable, right? I'll give you the scratch paper just like we had before. Make sure you write your letter choice down. And I know the computer doesn't give you a letter choice, but you can assume the first one's A, the second one's B, C, D. Does that make sense? So if you write the letter choice down, I at least know what you meant, okay? And that way we can, if I have to go back and hand grade or add something in because it didn't work, we can do that. And remember how you got the spinning thing? Okay. I can, after the fact, force your test to finish. So if it happens that you can't get it submitted, I can take care of that for you on my end, all right? But I know there were a few of you that were finishing right at the end, and it wouldn't take your answers, right? So that's why backup plan is make sure you're writing your answers down on your answer page, okay, on your scratch paper, okay? All right, then we at least have it covered. And on those, what I'm going to do is we're going to split it. You'll notice the study guide was split into 2 days, right? So you know exactly what's coming Monday and you know exactly what's coming Tuesday. There shouldn't be any surprises, okay? So I am recording, so you guys will know what, I will try to get it posted even today, okay? If I can, I might try to get it even done before the end of the day, okay? Since I don't have to teach anything but you guys today. So let's go ahead and start. We're going to go back to trig. I know it's been a few weeks since we've been in trig, all right? So let's see what we can do with these. So cosecant, the easiest thing to do, we usually do, is to try to turn things into sines and cosines, right? So let's try that. Let me get this back up. What? You're excited for this final? Okay. As long as Diego's excited, we're good, right? Okay, what's another name for cosecant? 1 over sine beta, okay. And then we've got cosine beta. And then technically in the denominator here, what's another name for tangent? Or cotangent. Cosine over sine. We can't really do any canceling quite yet, but I do need to do what with this to get it upstairs? I could flip it, right? And switch it to multiplication. So cosine beta, and then this turns into sine beta over cosine beta. Now what am I able to do? Cancel the cosines, cancel the sines, so what are we left with? 1. Okay? And again, we're not doing any verifying little proof things on this, are we? Okay? You're basically looking to get one of the multiple choice answers. The entire final is multiple choice. Okay? Oh, yeah? Yeah. I'll go back. What's wrong? Question or just need to get it written? Okay. All right, we good with 1? All right. Name the trig function that's equivalent to the expression. So what 1 minus sine squared? The answer's on the window, isn't it? What's 1 minus sine squared?
Cosine.
Cosine squared x. Done. Okay. Pretty easy so far on the trig. I think the trig is very easy compared to a lot of what we did. All right. This one says write it in terms of sine or cosine. So what, I'm looking at this function right here. What's another name for cotangent? In terms of sine and cosine. Cosine over sine, good. And what's another name for cosecant? 1 over sine. All right, so this one, It says it wants it in terms of sine and cosine, so I'd leave it as cosine x over sine what? Squared x. That's probably where I'd leave it. I'll go back and double check and see what the final does to make sure we're doing that one right. Okay. I need to make sure I look that one up for us. Let me circle that one. So to make sure I go back and look. All right, let's look at 4. Write an equivalent expression to this. So what could I factor out? What is instinct kind of telling you to do? Yeah, let's take a secant squared out. And then what's left behind? Tangent squared plus what? 1. And then this looks awfully Pythagorean, doesn't it? So what can I replace tangent squared x plus 1? Good. All the heads turned. That's good. We know where to look. Secant squared x. And just so you guys know, all the other the other teacher that teaches calculus, he has all these things up on his wall somewhere too. Okay? So when you get there, if you end up with the other teacher, they will still be there for you. We don't use them that often, but they're there. Okay? I told you, 0 period.
Can we take a picture of it and get extra credit?
And get extra credit? No. For taking a picture? Yeah. What's secant squared times secant squared? Secant to the 4th x. All right. No, I'm not sending you on a scavenger hunt. All right. That was more to annoy Miss Dudley than anything else. All right. So find a solution to the given equation. All right. So I got to do what with this? What do I get to do to get x by itself? Move the 1. So how do I move the 1? Add it. Then what am I going to do? Divide by 2. So now I'm on my unit circle. I know it's been a few weeks since we've done unit circle. You were looking, is the cosine the x value or the y value? X value. So you're looking at, there should be 2 places where the x value is positive 1/2. What are they? Pi over 3. Where's the other one? 5 pi over 3. So quadrant 1, quadrant 4, right? It's where the cosine is positive. Is it possible that, because notice it says find a solution. Maybe both of those won't show up, right? Maybe only one of them will show up. So make sure you read. So I find all the solutions means you need to make sure both of them are there. Okay? All right. 6 says use the fundamental identities to simplify. This is looking kind of Pythagorean to me, is it? Let's see. 1 secant squared minus 1. What can I replace that with? Tangent squared. Okay, what's another name for tangent squared? Sine squared over cosine squared. What happens from there? Cosines cancel, so I'm left with sine squared x. All right, let's look at 7. So it wants us to sketch the angle 550 degrees in standard position. Okay, it's been a long, long time. This was like the first week we got back from Christmas. Okay, so 550 is more than 1 revolution around, right? It's probably a good idea to know exactly how far around we have to go. So I'm going to do 550 minus 360. 360 is 1 revolution. So what is 550 minus 360? You all have calculators. 1 what? 190. Okay, so that would be 1 revolution, and then we know up to here is 180, right? So I'd be just a little bit beyond it, so somewhere in there. So remember, you start here, you go 1 full revolution around, and we would stop there, and then you just label it 550. It's multiple choice. You're going to have to pick the correct picture. Okay? So I'd make sure that you understand about how far around you got to go. This is really the key right here, right? It's making sure you know where that it's going to finally land, or its coterminal angle is. All right, we got to convert to radian measure. This formula will not be on the test. Okay, so you're going to have to know this one. To convert to radian, I got to get the pi out of it. So it was either pi over 180 or 180 over pi. Those were our 2 choices. So what do I have to multiply this one to get rid of pi? 180 over pi. Okay. So because that allows the pi's to cancel. And either I can put it in my calculator and figure it out that way, or I can simplify my fractions. How many times does 12 go into 180 nicely? Okay, what goes into both 12 and 180? 6 goes into 12 twice and into 180. Oh, 12 went in there. 2 goes into 12 how many times? 15 times 5 is? How much? Ends in a 5. 75. There you go. Alright, we good with 8? So far the trig really hasn't been that bad, right? Alright, we have to use our calculator to do this. I, of course, don't know how my calculator up and going this morning. So what I want you to do on your calculator, okay, is you have to find the right buttons again, right? I can get mine going, but you guys start looking for them. First of all, we should be in... I think you need to be in degree mode. So everybody switch your mode to degrees. Everybody remembers how to do that? Okay, so everybody gets switched to degrees. And then there are a couple of places on the calculator there that actually get us to the degrees, the minutes, and the seconds. Let's see, mine will take forever to come up. All right, everybody got to the degree mode? He's not here. He's in AP testing this morning. Okay. So from there is a couple of places. All right. You could hit C over here on the, it's on the right side of the calculator. If you start by typing in the 34, and then on the right side of the calculator, there's a button that says question mark, exclamation point. Do you everybody see that button? It's next to the G. And then you type, and then the little degree symbol is there. And then you hit that button again. And you type the 22. So we type in the 22. You hit that button again. And it gets you the minutes. So the minutes is right next to the degrees. It gets you this little symbol. And then this is kind of almost the longer way to do it because you have to keep hitting buttons. You type the 15. You hit that button again. Oh, the seconds are right underneath the question mark, aren't they? So the seconds are under the question mark, and you hit enter. Oh, no, they're not. That's a quote. Sorry. So do 2 minutes, and I think that becomes the seconds. You do the minutes twice. I'll show you the other place to get it to, because there is another place that's better, maybe quicker. I didn't change my mode. I got this 0.599. Or did I do it wrong? Okay, what mode was your calculator in? Was it in degrees and you got that? Mine was in radians and I got that. Nope, not that button. Let's go to degree. And hit make default. Yeah. Okay, so when I moved it to degrees, where it should have been, I got 30, so it should have been 34 point something. Yeah. So this one was wrong because I was in the wrong mode, right? It has to be in degree mode. And you have to know, it doesn't tell us anywhere to change it, right? You have to know to change it to put it in degree mode. And it should make sense. To go to decimal, this is a whole number, right? It shouldn't change that number in front. What you're really putting in decimal is this piece in the back. Okay, let me see if my other calculator came up here. And I can show you the other one. So there was a second way to get to it. Let's see. Let's see if there it comes. So if I'm on my little scratch pad, and you see the button next to the book. Is it in there? No, it's the book. We have to hit the book. Was it? Oh, yeah, this one right here, right? That one's even better because look how fast we got to it. And then you just type in the 34. My calculator's probably in the wrong mode. It was 34, 22, 15. And if one of them's missing, you can just leave it blank, right? Or put a 0 in. And again, look, it tells me my calculator's in radian right there. I'm definitely in the wrong mode. So I'd want to go, if you find that happening, you want to change your settings. And you may have to, on this test, go back and forth on your settings. So you will be allowed to use the graphing on the test. Okay? So I'm going to copy and paste that and see if it'll give me. And now I need to hit the Control-Enter to get the decimal, right? All right, we good on degrees, minutes, seconds? I know we haven't done that in a while. Okay. All right, let's take a look at the next question. All right, so number 10. We need to, looks like we're back into right triangle trig. Find the exact value of the secant of theta in the triangle below. If B equals 15 and C equals 17. So if this is 15 and this is 17, how do I get the third side? Pythagorean theorem. So a squared plus 15 squared equals 17 squared. What's 15 squared? 225. What's 17 squared? Don't forget they're on the walls, right? The walls will not be getting covered for the test. All right, what am I going to do to move that over? And what do you get? Good, and we take the square root of both sides, so what's a equal to? 8. We didn't answer the question, though, did we? It wants me to find secant theta. So secant in SOHCAHTOA world is what over what? Hypotenuse over adjacent. What's your hypotenuse? Good. What's your adjacent? 8. And notice, that one was a triple, wasn't it? It is one you could have memorized. It isn't as common. Hopefully on the test, it's like a 5, 12, 13, or a 3, 4, 5, right? So you don't have to go through the Pythagorean theorem. All right. Use a calculator to evaluate the function. Round your answers to 4 decimal places. Be sure the calculator is in the correct angle mode. What angle mode should we be in? What's the clue? Should be in degree. Okay, so let's all do that together. Because you remember, if you don't have one of these at home, you're going to want to practice on these. Okay? If you are planning on going to calculus next year, in early August, they start running sales on the calculators. I highly recommend, especially if you are a sophomore, okay, I'm going to take a couple years of calculus or take Calc and Stats, that you get one, okay? So I would make sure that, leave it in degree, because it had the degree symbol. Okay, so I'm getting 0.9099, or 9, oh, it's going to round all kinds of places, isn't it? Let me do this. Copy. It was right next to, it's the question mark button. That's how I got the degree. Did I have to put the degree sign in there? Not really. It would have worked without the degree sign. As long as my calculator was in degree mode. If it was in radian mode, I can force it to degrees by using the degree sign. All right, so I need first 4 decimals, which is really that, but with the 6, I really should round it, right? So 9, that's going to round this to a 1. Oh, wait, is it going to round that to a 1 too, isn't it? Did I do it right? Did I round right? I hope. With this, would you be able to pick the right multiple choice answer? Yeah. Okay. Even if we rounded it wrong, right? Okay, we got to solve for y. Couple of ways you could do this. You could use sine, cosine, and tangent. Okay. Perfectly valid, but what if your answer is not in decimal point? Because I'm going to guess the answer is not in decimal point. Remember how we had 30, 60, 90s, and 45, 45, 90s? That falls into this category. Okay. So this is where you probably need to know these formulas, and these ones won't be there. So there's a few formulas you got to know. Not many, okay? So this is the, remember we do short and long leg. This would be the long leg. This is the short leg. And this one is the hypotenuse. So we know, just so you have it written in one place, hypotenuse equals the short times 2, and long equals the short times radical 3. Doesn't get much better than this. So likely what will happen is one of your answer choices will be the double of 43, right? And one of them will be 43 times square root of 3. So long is y, 43 is short. Not much other than that to it. So that was really, do you know your formula? Okay. And we didn't give you one where you have to go backwards and start with the hypotenuse and get the long leg. This was really straightforward. All right, looking at 13. Cosine of theta equals, and it says the negative square root of 3 over 2. Find the value of theta in degrees without the aid of a calculator. So yes, you're going to have your calculator, okay? But basically what they're asking you to do is use your unit circle, okay? I don't know why it's stopping at 90, because that's definitely not in the first 90, is it? So I think that this might be a typo here, okay? So we'll see what happens. I'm going to double check that one on the test too and see what we did with that. So you're looking for x values or y values? X. So go on your unit circle, and remember we want this in degrees, not in radians. And I don't think the unit circle in your book is in degrees, is it? It's just in radians. All right. So what are we getting? There should be 2 places in theory. So what are the 2 places? Okay, we want it in degrees. One more time, I'm sorry. And 210. Okay. So even if they only wanted 1, or if it was in some weird interval, if you looked it up on your unit circle, would you be able to figure out which one it is on your multiple choice? Yeah. So even though you know there's 2, they might narrow it down to 1. Okay. And it's probably going to be the one that's, and watch the interval. Obviously, if there is an interval and it's valid, you would want to pick one that's actually inside of it. Okay, but I'm pretty sure that's got to be a typo on here. All right, what is this question really asking in 14? What's the key word in here? Coaching. They're looking for this, right? Even though they stated it funny, that's what they're looking for. The wording shouldn't freak you out. Okay, you shouldn't have a problem with that wording. So we've now gone over it, and I know we went over it before we did the test on this. Is this on the unit circle the way it looks? There are 2 ways to get it. Could we count it? Remember how we counted things? Pi over 3, negative pi over 3, negative 2 pi over 3, and we pick that one. Okay, or we would add 2 pi to it, right? Plus 2 pi. What's a better name for 2 pi in this case? 6 pi over 3. So what's negative 2 pi over 3 plus 6 pi over 3? So it's the same thing as finding the cotangent of 4 pi over 3. Okay? So on your unit circle, cotangent is the what over the what in this world here? Cosine over the sine. So I want you to read me the x coordinate and then the y coordinate. So what's the cosine in there? Negative, is it 1/2? Yeah, over what? Good. All right. Double negative is going to go what? That makes sense for cotangent in quadrant 3, right? What else can we do? Cancel the 2's. Okay, you're going to be pressed for time on this test, right? I'm giving you the class period. In fact, if you want to come in, get the Chromebook out and get started, okay, I'll make sure the passwords are posted when you walk in the door, okay? You're pressed for time on this test. I'm not looking at work. What do we automatically rationalize that with? Yeah, and a lot of you probably have the fact that 1 over square root of 3 equals square root of 3 over 3. Do you need this step? Would you possibly be able to pick out that multiple choice answer without doing the work? Probably. Okay? We've done that calculation I don't know how many times, countless times this semester. Okay? Even though I know it's been a few weeks because we went into all this stat stuff. Huh? Stat stuff is there too. So that's good news, right? All right, properties of inverse trig functions. This is probably the easiest question on the test. What happens? Please, please, please do not get this wrong. Do you see how nice we were? We picked the nice problems. Tried really hard. All right. So we're going to use the knowledge of vertical translations to graph two cycles of the function given below. Okay. So we have tangent of x plus 2. So first of all, which ones are not tangent graphs? Are not candidates for it? D and C are out. Those are either secant or cosecant, right? So we know these other ones got to be tangent. Does tangent tilt in kind of the positive slope direction like that, or in the negative slope direction like this? So what can I eliminate now? A is gone. That's more like a cotangent, or if we've got a negative, funky negative on a tangent, which we don't have. What is this doing to it? Moving it up too. Which one looks like it's moving it up too? B. So not a whole lot of work we can show, right? It's a lot of reasoning in our head. But this is one where while I'm taking the test, I'm also writing that answer choice down on my piece of paper, okay? Just in case something goes wrong with the computer, right? All right, now we're back into what we've been doing the past few days. So the median, what do I have to do first for median? Put them in order, okay. So what number am I going to start with? Looks like 17. Okay, what's next? Looks like 24, okay. And then what? Good. And then what? 27. All right, then what? Oops. I don't know why I want to write 28 right now. 28. Okay, now what? 37. Okay, then what? 38. 39. 40. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I've got an odd number, so I get to go right to the middle. What's right in the middle? 28. What if I had an even number of numbers? Add both, divide by 2. Good. What do you think some of these other answers are up here? One of them is going to be probably the mean. Okay. There wasn't really a mode, was there? But that's another good one that they'll put up there to try to confuse you as the mode. One of them might be adding two of them together and dividing by 2, saying that you maybe messed that up. Okay, in fact, that might be kind of what they were going for with this one here. It isn't quite, but could be what they were going for. All right, we had this question the other day, didn't we? Yeah, and it's up on the final too. What do you know? Some of these questions that are on the final are on our tests. We were pretty lazy when we wrote this, weren't we? We just went back to the old tests and grabbed the questions. All right, so 15 mothers were asked how many months old their baby were when they cut their first teeth. The results are below. It's a different set of numbers than we had before, okay? Oh, this poor mother, 1 month old. That's ridiculous. That's got to be a typo. So it looks like what's your outlier look like it's got to be? Looks like it's got to be 1. You see, because look at your choices. It's either 1 outlier or no outliers. So we're going to go with the 1. All right. Then we've got to deal with the range. So the range, how do we get the range again? Biggest from smallest. What's your biggest? 10. What's your smallest? And what do you get for your range? 9. So in this case, it was answer choice B. Okay, how are we doing on time? Oh, we got lots of time. You guys okay if we just try to accomplish day 1 today?
Yes.
Okay. I'm going to keep going while we've got, and then tomorrow we'll try to see how much of day 2 we can get through. All right. Okay, every 6th student, so we're supposed to match the sample with the sampling method. Every 6th student on the class list, convenience, random, systematic, or self-selected? Systematic, good. Not much to these ones, right? Student calls a radio station. That one's self-selected. Good. They probably were. Okay. First 35 students who enter the office. That would be more convenience than it would be random. Okay. So random, remember, is we kind of survey everybody kind of thing and make it so that they can't select out of the survey somehow. It usually has the word random in it too when it's random. All right, let's keep going. We're going to try to get up through 24 is the goal right now. Even though I only told you to do the first 20, right? Okay, at Rose's summer job with the research company, she must get a representative sample. Okay, remember representative is another word for unbiased. Okay, of people from her town to answer a question about health habits. Which of the following methods could be used to get a representative sample? Selecting only people with incomes greater than $50,000 to respond. Okay, selecting people randomly by computer to respond. Gathering responses in her apartment building. Gathering responses in her neighborhood. I would go with B, right? Because if you wanted unbiased, you want it to be as most random as possible. Okay. This one, or these two down here would be convenience, wouldn't they? Okay. The first one, it's definitely, I don't know if it would even count. It's definitely a biased representative up here, right? I'm not sure which one category it would fit into, but it's definitely biased because if you're going $50,000 or more, that's not just being random because, you know, you guys could be getting the summer job, right? Or what is it? Yeah, it could be self-selected. Oh, health habits. All right, yeah, because people who don't make $50,000 might have different health habits than people who make more than $50,000, right? Okay. All right, we got to find the sum. So now we're back into sequences and series. Isn't that a fun jump? All right, so first of all, if we're going to find the sum, there were two sum formulas, okay? One of them was arithmetic and one was geometric. So we need to identify what kind of sequence we have here. So are we adding to get to the next term or multiplying? What are we adding? It looks like our difference or our common difference is 4. Okay, so we know we're doing arithmetic. Again, I will make sure you have the formulas for these, so don't panic about memorizing them. So you've got n over 2 times a sub 1 plus a sub n. You might not have the names of the formulas. I don't remember if we put that on there or not. So you need to understand which one goes to which thing. Okay? So now we're going to talk about, let's see. We know the first term, right? What's our first term in that series? 10. What's the last term? Do I know the number of terms? So there are a couple of ways you can do this. You could take your calculator and you could add 4 until you get to 78 and count how many numbers you have. That is a legitimate way of doing it. If this is like, 8,756, you might not want to do that. Okay? So what you would probably want to do then is probably use your a sub n formula as well. This is our tricky way of getting you to use both in one problem. Okay? So I know my last term is 78. My first term was 10. I don't know my number of terms, but we calculated that our difference was 4. And if I solve that, I should be able to get my n value, which I can then plug in over here. Okay? So what are we going to do to move the 10? Subtract it. What do we get? 68. I can do two things. Do you want to distribute or divide? Okay, distribute. So 4n minus 4. I guess I could have done that and then added the 10. So what do I have to do with the 4 at this point? Add it. What do you get? Good. And then what are we going to do with the 4? Divide it. What do we get? 18. N should never be a decimal. Okay? It should always be a nice, pretty whole number. All right. Now we're ready to find that sum, and it's sum sub 18. So what is 18 divided by 2? 9. 10 plus 78 is? 88 times 9 is? What is it? 792? Or do we have confirmation more than one person get that on their calculator? Okay, good. All right, we good with 23? All right, let's look at 24. Oliver works at an ice cream shop. The list below shows the number of hours he worked each day for a 6-day period. We had a question like this the other day too, didn't we? Maybe. Oh, no, we didn't. This one was just on the final. All right, find them. They gave us the mean of the data. They want us to find the standard deviation for these data. Okay, so I would probably still do one of these. Okay. They at least did some calculating for us, so we don't have to do all of it. They already told us that the mean is 5. So how do so to calculate the standard deviation, what do I have to do in the middle column? Subtract. We got to do the difference, right? So I'm going to subtract 5 from each one of them. So what do I get going down the column? What's 5 minus 5?
0.
0, then what? Good. 2, then. Good, then. And again, do the signs matter? No, there's no worries about our signs, because what are we going to do here? We're going to square them all. So 0 squared, negative 1 squared, 2 squared, and all the rest of them are 1. All right, I need to find the mean here. So we're finding the mean again, which really in this case ends up being what we call the variance. So add them up. What's our total when we add them up? It's 8. And we're going to divide that by 6, and we're going to get what? 1 point what? 3, it repeats. Okay. So that's the variance. To get the standard deviation, what do I have to do to that number? Square root it. So again, this one isn't technically a formula, but it won't be anywhere for you. You're going to have to know how to do the process. All right, so what do we get when we hit the square root button? What is it? 1.15. Do we all agree with that? Yeah? All right, so that takes us through day 1. All right. Remember, this is technically your last weeks of homework, right? So this is week, I think we're up to 17, okay? And I think it goes to 85, right? It should be 81, 82, 83, 84, 85. So the way I broke it up is it should be the study guide for the final. This is the name on it. Isn't it 1, 2, 10, 11? I just did this, right? I broke it into about 10 problems a day. 20. It's on haiku. Okay, 31, 2, 4, and the last one was just 7 problems or 6 problems or whatever. Okay, so tomorrow, make an attempt at Beyond 24 tonight. Okay, see, and we can probably blast through tomorrow the last half of this, and that way by Friday, I should have the videos posted and you guys can have some practice time. Okay, so if we get through it tomorrow, Friday can become a work day in class. You can work on performance tasks. You can work on studying for your final. Okay, sound good? Yeah. All right. So I'm going to hit stop on this thing. We can also make Friday a giant stamping day, because I know we haven't done that in a